Okay, in question number 2, we're asked about this particular function and we're asked for the maximal domain. Okay, so the x sits inside of a logarithm. Since a logarithm only exists for x bigger than 0, therefore d has to be 0 to infinity, not inclusive of 0. I show that f can be expressed as this. Okay, so f of x equals 4e to the 3 log base e of x. If I put the 3 up onto the power of the x, it's going to equal 4e to the log base e of x cubed, and e log base e of x cubed equals x cubed. Therefore, 4x cubed is correct. Find the area bound by f of x. Well, f of x is the same as this, so it's going to look like a cubic, and we're going between 1 and 2. So the area is going to equal the integral from 1 to 2 of f of x dx, which will be 4x cubed integral from 1 to 2 dx, and that gives me 15 units squared. I'll write units squared because it's an area. Function g is the antiderivative of f through the point. So if I take without terminals, x to the power of 4 plus c, and I know that that will equal -5 given x equals 1. That's my given condition. So c equals -6. So g of x should equal x to the 4 minus 6. And we need to draw it over the domain of d, and the domain of d was 0 to infinity. So we're going to start here at -6. And if I've got x to the power of 4 minus 6, math 3 given x equals 1, that's -6. When x equals 2, that's 1. And x equals 1, it's -5. And if it equals 0, I want to solve for x to find the x-intercept. I get the cubic root of 6. Okay, so my curve's going to look like, and the cubic root of 6 is roughly 1.56. So that's g of x, that's 6 to the 1/4, that's 1 and -5, and that's 2 and 10. Label the coordinates at the endpoint. Done. I'll do 0, -6. The x-intercept, done. And the point on the yep, done. So that's my graph. Let A be bigger than 0.5. The area bound by the graph of f of x. So that is the 4x cubed graph. That's not the graph that I just drew. The graph that we just drew was g of x. That's the graph of g of x, which is x to the 4 minus 6. We're now looking at f of x. But what we do know is that the integral of f of x dx equals g of x. Okay, so I want to know the area bound from the graph of f of x, and f of x is the cubic between the lines of 0.5 and a. Okay, so that area will equal the integral of f of x dx from 0.5 to a. And that's going to equal g of x from 0.5 to a, because g of x is the integral of f of x, which will equal g of a minus g of a half. And g of a half is, this is g, math 3 given, x equals 0.5 is minus 95 on 16. And b equals negative 95 on 16. Okay. Okay. Part 8. Consider this final quadratic expression for the derivative. Okay, so this is about f of x. So let's get f of x, and f of x is 4x to the power of 3. And I'm going to define f of x as f of x. Done. So now I want f of x, but it's minus f of x. It's f of 2x minus 3. So there's my f of 2x minus 3, tick, minus f of x, done. And I want the derivative of that. Quadratic expressions, it's just worth 1 mark. H dash of x equals 84x squared minus 288x plus 216. Hence or otherwise, find the coordinates of the point of the graph where the gradient is a minimum. Okay, so if I want to minimize this, the coordinates of the graph where it's a minimum will be f min of h dash of x, and that will give you 12 on 7 and negative 216 on 7. No, that's the gradient. I need to go back to this expression, and into that expression I need to make x equal 12 on 7. So it's negative 972 on 49. So that's the y coordinate, that's the x coordinate, when the gradient is a minimum. Now, over the interval 1.5 to p, what size is this value? 1.7, so that's bigger than 1.5. 1.5 to p, strictly decreasing. Okay, so my graph gradient is a minimum at that. So my graph is going to, graph of H, what does that graph look like? Okay, 1.1, there it is there. And the gradients here, that graph is to the minimal. So analysis G cell max 1.18, analysis G cell min analysis G cell inflection. So there's my inflection, and that's the point we're looking at, 1.71. So that's when it's the gradient of H strictly decreasing. So I want f dash of x strictly decreasing. So it's going to be from 1.5, this point, to 12 on 7. So therefore P equals 12 on 7. So it took a while to get there.